In this video, I'll be going over tangent and cotangent graphs. We'll first begin with the tangent graph. So here's the parent function for y is equal to tangent of x. So here are some values for tangent that we would get from the unit circle. Now what we notice is that at negative pi over 2, the tangent function is undefined, and at pi over 2, it's also undefined. And this is coming from the unit circle. So if we look at negative pi over 2, the coordinates at pi over 2, at negative pi over 2 are 0, comma, negative 1. So tangent at negative pi over 2, well, tangent is the y value over the x value, so it's negative 1 over 0. Well, when we divide by 0, that's how we get an undefined value. So that's where these values are coming from. So what we notice is that as x is increasing, so as we're going to the right along the x-axis, the value of the function is increasing. So as we go to the left, this curve is increasing. And that keeps happening in each period for the tangent graph. And then the places that the function is undefined, that tells us where the asymptotes are. So the things to remember about the tangent function are we're undefined at these asymptotes. The graph is increasing. And what we notice is that, let's take this period length between negative pi over 2 and pi over 2. Well, half of the period is less than 0. Half of the period is above 0. So this is different than all of the other trig functions. All of the other trig function graphs begin at 0. Their first period begins at 0. Tangent, what we could say is, well, half of the period is to the left of 0, half of that period is to the right of 0. So how I describe this is the fundamental period. I say that it straddles. In other words, half of it is on one side and half of it is on the other side, 0. Next, let's look at the cotangent function. And again, I've listed some values that come from the unit circle. And we have a couple places where cotangent is undefined. It's undefined when x is 0 and when x is pi. So again, if we think about the unit circle, at 0, an angle of 0, the coordinates there are 1, comma 0. Well, cotangent of theta, so at this position, 1, comma 0, that's an angle of 0, and cotangent is the x-coordinate over the y-coordinate. We get 1 over 0. This is why this function is undefined. So we will get cotangent being undefined anytime we have a y-coordinate equal to 0, because that'll end up in the denominator. So that happens at 0, at pi, at 2 pi. So at any integer multiple of pi, that's where cotangent will be undefined, and that's also where the asymptotes are going to be. So one thing that is different about cotangent from tangent is that the function is always decreasing. So tangent is always increasing, but the cotangent function is decreasing. So we say it's decreasing. We have asymptotes here and here. And then one thing to note is that the fundamental period, or in other words, the first period, begins at 0. So this is also more in line with all the rest of the trig functions. The first period for the parent function is always beginning at 0. The only one, again, that does not begin at 0 is tangent. So let's go through the steps for graphing a tangent or cotangent function. We want to write the equation in standard form. So here are the two standard forms. So this is very similar to all the rest of the standard forms for the other trig functions, but just in place of tangent or cotangent, or I should say tangent and cotangent are in place of where the other trig functions would go. We want to find the period and any vertical and horizontal shifts. Well, the vertical shifts are going to correspond to D. The horizontal shifts are going to correspond to C. Sometimes the horizontal shift is called a phase shift. One difference, though, for the period length is that the period length is pi over b. So this is different than what we saw in the other four trig functions. Sine, cosine, secant, and cosecant were always 2 pi over b. So this is a difference that we need to remember. Then we determine where the graph crosses the horizontal axis and where the asymptotes are. So the period for a tangent graph, what I said is that it straddles 0 with asymptotes above and below 0. So let's go back to the tangent graph. So what we see is this first period, I'm drawing the asymptotes. So I have this length right here is the period length. Half of the period is below 0, half is above 0, and then I have the asymptotes at the beginning and at the end of that first period. The period for cotangent begins at 0, and it still has asymptotes at, how do we say this? At 0 and the end of the period. Okay, so if we look at, this is the cotangent graph, so 0's here, we have an asymptote here, that's the beginning of the period, and then the end of the period. We said the period length is pi, so that corresponds to where then the second asymptote is. Next, we want to find the equation for the asymptote lines, and this is going to be the same for secant and cosecant. We're going to say y is equal to any asymptote plus k times the distance between asymptotes. Okay, and k here is any integer. All right, so we keep k in the equation for the asymptote line. So basically what we're doing is we're coming up with a formula for a way to find all the possible asymptotes that the equation could have. And then we apply any horizontal and vertical shifts, and then we'll draw a smooth curve. One last thing to mention that we want to always remember is that tangent is an increasing function, cotangent is decreasing. All right, so let's look at an example of each of these to come up with the graphs. All right, so here's our example. Y is equal to tangent of x minus pi over 4 plus 1. We want to graph the equation and find an equation for the asymptotes. Okay, so let's write this into standard form. The leading coefficient is 1, tangent. There's no coefficient on x. Well, it's a 1, so we can factor out a 1. And then plus 1 on the backside. So the period length, remember, is pi over b. Well, b is 1 right here. So we're going to say this is pi over 1, or just pi. We don't talk about an amplitude when we have a tangent or cotangent graph. This value right here is corresponding to a vertical stretch. So because it's 1, there's no vertical stretch. Frankly, it's hard to accurately portray a vertical stretch when we're graphing tangent and cotangent. So when we're graphing these, we don't really need to worry too much about that. So for the horizontal shift, that corresponds to this pi over 4. So we're going to say right pi over 4 units. And then this plus 1 is telling us that we have a vertical shift of up 1. Okay, so let's look at the period length. The period length is pi. So because it's pi, half of pi is going to be below 0. Oops, half of pi is going to be below 0, and half of pi is above 0. And then because we're shifting to the right, pi over 4 units, we're going to add pi over 4 to each of those values. So we end up with is, well, 0 plus pi over 4 is pi over 4. Negative pi over 2 is the same thing as negative 2 pi over 4. So negative 2 pi plus pi is negative pi over 4. And then pi over 2 plus pi over 4 is going to be 3 pi over 4. So these are the values we want to use. And what this means is that at negative pi over 4, which is the beginning of the period, we're going to have an asymptote. And then at the end of the period, we'll also have an asymptote. And the middle value is where the curve is going to cross the horizontal axis. So when we think about graphing this, we need to move everything up 1 unit, because that was the vertical shift. And we're going to have an asymptote. Nope, we're not going to have an asymptote there. We're going to have an asymptote at negative pi over 4. So how about right here? And then we'll have an asymptote at 3 pi over 4. And then it's crossing the horizontal axis in the middle of that period length, which is pi over 4. So I want to put it here because that's where it's shifted up 1 unit. So the curve, tangent is an increasing graph, so we're going to increase along the asymptotes, and then we're going to go towards the other asymptote. So the graph looks something like that. It's not very symmetrical. Let's see if I can do a better job here. I don't know, maybe that's slightly better. So that's the image of the graph. Now I could do a second period. So to fit this on the graph, I'm going to do it to the left. So I'm going to have an asymptote here. And that asymptote is going to be negative, start at negative pi over 4, but I'm going to move left pi over 4, so negative 5 pi over 4. And negative 3 pi over 4 right here is where that graph is going to cross. So the graph is going to look something like that. So it's just that image repeated infinitely. So let's come up with an equation of the asymptotes. So again, we pick any asymptote. I could pick negative pi over 4, I could pick 3 pi over 4, I could pick negative pi over 4. Oftentimes we'll pick the first positive asymptote. It's not a requirement. 3 pi over 4 plus k times the distance in between these asymptotes. So the distance from here to here is pi, and it actually corresponds to the length of the period. So y is equal to 3 pi over 4 plus k pi for any k integer. I could have also said y is equal to negative pi over 4 plus k pi. I'm just picking a different first asymptote. So there are actually an infinite number of equations for asymptotes we could come up with because there are an infinite number of asymptotes. So I could put any value there in the circle. And then let's look at an equation of a tangent function, or cotangent rather. This is a tangent function. All right, let's do the same thing. Y is equal to 1/3 cotangent of 4x minus 2 pi. So we'll write this first into standard form. Y is equal to 1/3 cotangent. I'm going to factor out the 4. X minus, when I divide 2 by 4, I get 1/2. So I could say pi over 2 plus 0. Now if you're not seeing how I factored this, just multiply or distribute out, and you'll see that you ended up with what we started with. So the period length, again, is pi over b. So b is 4, so we're going to say pi over 4. We're shifting to the right pi over 2 units. And there's no vertical shift because we just have plus 0. And then again, the 1/3 that doesn't correspond to an amplitude, that is just a vertical stretch or compression. Because it's below 1, that would be a vertical compression. So let's consider what the period looks like. So cotangent always begins at 0 and ends at whatever the length of the period is. So pi over 8 is halfway there. I didn't mention this for tangent, but it's the same thing for tangent and cotangent. We don't need to get the quarter points. We don't need to find these values. We only need the beginning, middle, and end for tangent and cotangent. So we're shifting to the right pi over 2. So we're going to add pi over 2 to each of these values. So from 0, we're going to add pi over 2. And then I need to add pi over 2 to each of these other values. Pi over 2 is the same thing as 4 pi over 8. So this is going to be 5 pi over 8. It's also the same thing as 2 pi over 4. So 2 pi over 4 plus pi over 4 is 3 pi over 4. All right, and remember we're going to have asymptotes at the beginning and the end of the period length. There's no vertical shift, so it's going to cross here. And then cotangent is a decreasing function. So when we graph this, we need to make sure that we're decreasing. All right, so let's plot these values from the number line. I'll have pi over 2, 5 pi over 8, and 3 pi over 4. There are the asymptotes. There's no vertical shift, so the graph is going to cross in the middle at 5 pi over 4 along the x-axis. And then remember, a cotangent graph is decreasing. So the graph is going to look like that. And again, we could give a second period if I'm moving to the left. So I need to, if I'm starting at pi over 2, I need to subtract pi over 4. Because pi over 4 is this period length. So that's 2 pi over 4 minus pi over 4. Oh, this is kind of out of whack here. Well, pi over 2 minus pi over 4 is going to be pi over 4. So we're going to say, I'm going to say that my y-axis is here. And so this value is going to be 0. So both of these periods are going to fully be in the positive, on the positive side of the y-axis. So halfway here is going to be 3 pi over 8, and then the curve is going to be decreasing. So the graph looks something like that. And then let's come up with an equation of the asymptotes. Y is equal to, pick any asymptote. I'll pick pi over 4 plus k times the distance between asymptotes, which in this case is just the period length. And that's it. That's how we graph tangent and cotangent.